Hello class. So your homework is page 22 and just number 3. Remember when you're solving these, I'm writing down the steps again. 1, read the whole problem, not part of it, the whole problem. 2, draw and label a picture. 3, write out variables and numbers. 4, find an equation, so one that matches your variables. And 5, solve it. So go ahead, try number 3, and then I'll go over it with you. Alright, step 1. Frustrated because of all of the AP summer homework, Issa climbed to a high cliff and proceeded to throw her physics book down with the initial velocity of 10 meters per second. Alright. A, if the book takes 3 seconds to hit the ground, how high is the cliff? And B, how fast is it moving when it hits the ground? Alright, so this is a 2-part equation, so you will need... So we read the problem. Next is drawing the picture. So let's just do A for now, and we can just talk about B a bit. So again, it's just reading the first part, so we got Issa. Let's give her a ponytail. High on this cliff. And she throws her book straight down. It's open. Think of it that way. The book flew open. Anyway, so she threw her book down, and its initial velocity was 10 meters per second. And we also know when it hits here, that is 3 seconds. And we have no idea how tall this cliff is. So you do on your drawings either want to say which is up and down. Again, I'm going to call this positive, and I'm going to call this negative. I'm going to call where it hits 0, and therefore where it started from is going to be some positive number that we don't know. So I've kind of already gone into the 3rd step where I'm starting to write variables, but I still want you to write them down in a list so they're easy to see. So also, our V naught, remember I said down is negative, so that must also be negative because she threw it in that direction. Then I know we want to figure out where it started or how high is the cliff. We do know where it landed, aka 0. We know that time-wise it took it 3 seconds. And remember, after she threw it, it's being affected by gravity. She gives you negative, I'm going to do 10 meters per second squared. If you did negative 9.8, it will get you a very similar answer. So do not worry about that. Next, we need an equation that can help us with this. I'm going to make a little bit of room here. So that equation would be x equals x naught plus v naught t plus a t squared. 1/2 at squared. So you can pretty much start plugging numbers in here. So your V naught is a negative 10 meters per second times time, which is 3 seconds, plus 1/2 times our negative 10 meters per second squared, times our second squared, which is 3 seconds squared. So 3 times 3, or 3 squared is 9, times 10 is 90, so you're going to get negative 90. And if you do this, it's the second squared. It's going to cross out with your seconds and the squared on them. So you're going to get 90 meters times 1/2. Let me draw that a little better. Times 1/2 plus negative 3 times negative 10 gives you negative 30. Seconds cross out. Negative 30 meters plus our initial, which we don't know, is all equal to 0. So I'm going to get rid of some of this up here to make it easier. Rewrite our equation. So we have 0 equals x naught, we're up here now, plus negative 30 plus 1/2 negative 90, so 1/2 negative 90 is negative 45 meters. So x equals x naught plus negative 30 meters. So remember, if you're having a negative 30 minus 45, that's the same as saying adding it to a negative. So your number is essentially just going to get bigger as far as negative goes. So it's going to be negative 30 plus 45, 75 meters. And if you have to do the math on this one, you can. But if x minus 75 meters equals 0, if we add this to the other side, we get, what was it, inopportune negative sign? We get 55 meters equals x naught. Hopefully this video was informative for you. Oops, I got ahead of myself. Still got to do B. Thought I was done. Alright, I erased some of the old stuff. I wrote in what we now know, that the distance was 75 meters, in case that's useful. And then B is how fast is it moving when it hits the ground. So again, write out your variables. So our initial velocity was, again, that negative 10 meters per second, because she threw it down. Acceleration does stay the same, because it's gravity, which is also going to be negative 10 meters per second. Squared, I rounded up to make the problem easier. We do know that time equals 3 seconds. So just looking at these, we don't even have to worry about position, because we just care about velocity. So hopefully you can look up your equations and see, oh, we want to know the final velocity. That's our unknown. So you need an equation that has final velocity in it, which the last one we used did not. It only had initial. So you're going to want the one that says final velocity equals the initial velocity plus acceleration times time. So again, you just need to plug your numbers in for this one. So you get negative 10 meters per second plus a negative 10 meters per second squared times that 3 seconds it took to get there. Your seconds cross out, at least one of them does. And you got negative 10 times 3 gives you negative 30 meters per second. Negative 10 meters per second. And you can basically add these negatives together, giving you a total of negative 40 meters per second. So it should be a negative number that you got. If you said down was negative, if you said down was positive, you will still get, should get a positive 40. Alright, hope this video was informative. Have a good rest of your weekend.